Okay, everyone. So now that we have at least learned how to query against GraphQL, let's take a bit of time to understand how we can leverage GraphQL and Apollo to replace the existing Redux implementation we have inside of our applications. Now, you can use GraphQL alongside Redux. It's not impossible. The only issue with doing so is that you end up running two different kinds of front-end state management libraries if you decide to use Apollo. Generally speaking, the information around whether or not to use GraphQL and Apollo alongside Redux is not fully fleshed out yet. There are people that have done it, and there are people that advise against it. In my personal opinion, I am going to teach you everything about Apollo replacing Redux in our front end, and then at that point, you can at least be equipped with the tools required to decide for yourself whether or not Redux with Apollo or with just Apollo alone is a better solution for you when you decide to use GraphQL. Personally, I would see benefits in both. Redux has a really fleshed out architecture and ecosystem that is really easy to learn and use once you've become familiar with Redux's structure. GraphQL and Apollo, on the other hand, are still relatively new. So Apollo does not have that much almost community support answering a lot of the questions that you might encounter if you try and just use Apollo alone to manage your local state. You might encounter unique cases where it's difficult for you to actually figure out how to leverage local state with the same robustness that you would be able to do with Redux. But that's simply my personal opinion. It's entirely up to you how you want to do it. I just want to equip you with all of the tools so that you can do it best. Now, before we actually move on to any of the coding, we have to understand what the structure of Apollo versus Redux will be. So in this diagram here, we can see how we currently have our application set up using sagas as well as Redux. So here we see that we have our reducers, which pass our state as props to our components. And here's where we have our selectors, which would pluck off the specific properties that we want to leverage inside of our components. And then our components end up firing actions using dispatch. These actions will hit the middleware before they end up hitting the reducers, but at this point, the middleware is able to use those actions and fire off different asynchronous event handling middleware that we are familiar with now, such as thunks, sagas, etc., which could fire more actions, or they might fetch data from our Firebase application. So we'll end up fetching our data from the database, which would then end up firing more actions so that our reducers get updated with this data. So this image represents the flow of everything that we've done up until now. Now, if we were to replace this with Apollo and GraphQL, this is what it would look like. So we still have components. And we have now, instead of our reducer, this thing called a local cache. So the local cache is this thing that Apollo provides us so that we're able to cache data on the client side, the same way that Redux does it. We're able to access this cache from anywhere inside of our component tree, the same way we can with Redux Connect. The only thing is that in order for us to get data or modify data on this local cache, we have to do so through a query or a mutation. Now, a query, as we know, is a way for us to request data from our backend. But the way that Apollo has it set up is that you would make the exact same query request for any data on your local cache. So you can almost see it as if you have two places where there's data. You have a local cache and you have your backend database. Pretty much the same way that we have Firebase as our backend database and Redux as our local state. The local cache that comes with Apollo is the exact same idea. The only difference is that the only way that you can make a query or mutation against your local cache as well is to use a query or a mutation. Now, what is a mutation? A mutation is simply any code that is not simply trying to read against the data. You want to write against the data. You either want to update it, add something to it, or delete it. So that's pretty much what mutations are. In GraphQL, as well as Apollo, they separate them into two different things. Queries simply get data, mutations modify data. Now, the way that we actually need to define to our application, as well as to Apollo, what we're able to query for or modify, we do in this thing called a resolver. Now, the resolver you can kind of see as a function, very similar to our reducers. The only difference is that that function, that resolver function, once it's called, will either modify some data or get some data. So it's simply a function that has access to the local cache and fetches data and then plucks off the data that you want to display, or it allows you to merge data together on a local cache so you can perform some specific type of function in order to update the local cache. Now, although that might sound confusing, but it's pretty much just the place where we have to write our code that defines what types of queries or mutations we have access to inside of our application. So just keep this in mind because we will end up writing resolvers inside of this section. Now, these resolvers are also going to be the type of resolvers we have on our backend that allows to do the same thing to our database. So if you were to ever look at a GraphQL backend server, you would also see resolver functions because those resolver functions is what allows the GraphQL server to know what exactly users are allowed to query for or allowed to mutate. So keeping this in mind, this is where the flow of data will be. Components will fire off an Apollo request. The Apollo request might check against our resolvers to see if it's a local or a non-local request. If it's a non-local request, it simply is an external query or mutation. It will then, depending on what it's looking for, get, update, or delete data on the backend, and it will send that over to our GraphQL server. Our GraphQL server then processes the request and it makes either a request to update data or get some data based on the SQL or no SQL database we actually have. So if that's successful, it will send that data back up and then through to our application and components where we can either store it on a local cache or we can simply use it in our components. Now, with Apollo, it will always cache that data for us so that we don't end up querying the same data because that is pretty expensive. So that's the great thing about Apollo is this local cache. We're able to not only leverage local data the same way that we can with Redux, but we're also able to automatically cache any data that we pull from our database so that we don't end up wasting requests. So this is kind of the flow that we're going to explore when we write in the upcoming lessons. So just keep this in mind. I know a lot of it is going to be brand new information and brand new patterns that you've never seen before, but this is at least a visual representation of what it is that we're going to build. And it's okay if it doesn't make sense even when we do those lessons, because Apollo and GraphQL are quite frankly quite complex to implement. So let's move forward with actually figuring out how this image looks like code.